Well, Dr. Maresco and fellow TAs, we are Group 888. Our team consists of Bhavya, Sarang, and myself, and our faces are presented to you right in front of you on the right-hand side right now. We are going to present you of our database design for our veterinary project. So let's start off with Bhavya and talking about the overall database design.
Hello. So let's talk about like all the tables and how they are related to one another via keys. So this is our ER diagram, which shows all the 8 main entities that we have, like animals, owners, weights, issues, photos, comments, users, and treatments. And we have 8 entities that store the next value of the primary key. We have this design because of the framework that we use Hibernate on the backend. So all these tables are connected to one another via foreign keys. So for example, animals are related to weights. So these tables like weights, issues, comments, and treatments via animal ID. So we all have we have animal ID in each of these tables, like animal ID, animal ID here, and the users and the user table is connected to these tables via different column names. So these column names have different names, like for weights, like it's W_recorded by. For issues, it is I_raised by. For treatment is for T_treated by, and so on. Now talking about the triggers. So we have we did not use any update and delete trigger because it wasn't required. So we created insert triggers that will actually update the values in these sequence tables as shown here. These sequence tables. So we have 8 different triggers for these. So each insert trigger for each of these tables.
So let's start off with the basic retrieval query. My name is Mike. So with the basic retrieval query, what we're going to do is that we're going to query all of the tables from all of the columns from the owners table. The owners table. Bhavya, can you show the query for the?
So yeah, first before we start with the query, let's run and populate our database. We'll just run the script. So as you see, the database and all the tables have been created. Now let's go to the query part.
Yeah, so the basic retrieval query, what we wanted to demonstrate is basically to go look at query all of the columns from the owners table, and then reassign the column names to the names as you see in front of you right now. So for example, our attributes are like, we have O_owner ID, we would rename it to ID, and O_first name, we rename it to first name. And the result is what is being shown in the bottom of the screen right now, with the first record being Damien Bruce Wade. So now let's go over a retrieval query with ordered results. So in here we presented you 5 types of queries that we kind of found it really useful for this project. So the first one is that we are going to get the maximum weight ever recorded for each of the animal, and then we're going to order by the heaviest animal as the first record, and then in descending order as you go down the record. Now, the second one is that we are going to query every column from the comments table, and then we're going to order by them in descending order. So the most up-to-date comment will be in the top. Thirdly, we are going to query all of the columns in the issues table where it is labeled as unresolved. So that's why it's I_is_resolved equals to 0. And then it will be ordered by the detected date in ascending order. So in this case, we're going to basically order these from oldest to newest where the issue is being unresolved. The next one is we're going to select all the columns from the treatment table, and then we're going to focus on only 2 animals with ID 14 and 18 respectively, and we're going to order it by its treatment date in descending order. Now, lastly, we are going to get all the columns from the photos table, and we're going to order it by the upload date in the descending order. So now let me hand over the mic to Sarang to explain a nested retrieval query.
So here we have the fourth query. And in order to illustrate a nested retrieval query, we thought, okay, we'll find animals belonging to owners that live in a manor. So how we did this is we're selecting all the columns from the table animals, and then we're looking specifically at the owner ID column. And then on that owner ID, we're adding another query where we select owner ID from the owners. So the animal references the owner, where the address is manor. So as you can see in the results there, this would be all the owner IDs that live in a manor. And then now moving to the fifth query, so retrieval query using a join table. So we have a lot of things going on here. So actually, if we go to the very bottom, let's start there. So what we're doing here is we're basically getting animal ID and treatment date in a descending order. So we just want to look at all the attributes of an animal table where the most recent treatment date is shown and the animal ID is also in descending order, so the highest animal ID. Now, if we scroll back up to the top, we can kind of dissect how this table is generated. So the first few lines there, animal ID, name, species, subspecies, those are just simple queries. So we're selecting for those. Now, when it comes to animal status, we have a case statement. So if the animal status is 0, then it's green. If it's 1, then we'll call that yellow. And then again, we also select further treatment description, drug name, dose, drug dose, delivery method. And then we scroll down a little bit more and we get just the first name, middle name, and last name. We're just retrieving that as one query and calling it treated by name. And then we're also pulling email ID. And then we just join it via right join and left join on the treatments and user table. So right join, basically, we'll just take all the treatments, value from treatments table and keep them, and only the matching ones from animal ID, and the other way around for the left join with the users table. And at the end, we get the result as we showed at the bottom there. So we have treatment date and animal ID in descending order. So the most recent treatment date is shown there. I'll pass it off now to Bhavya to talk more about update operations.
Yeah, so let's see what we have right now in the issues table. Let's just say like when we inserted an issue, we forgot to write the issue description. So this is another query just to see with whom this issue is related, and just in a way that how the issue are joined to show how they're related to the animal. So let's try to update the issue description to fracture. So the issue is now updated. The issue description is now updated. Let's get back and see the issue tables once again. So as we see, the description has been added, and if we see this join table, we can see like it's correctly represented here now. Now going to the moving to the next operation, delete operation. Let's just say that we want to this animal is no longer in the system and we want to remove this. So right now, let's see what this animal has in the system, like what comments, issues, and photos, and like what data this animal has. So it has 2 comments. It has no issues. It had no issues. It had no photos. It had 3 treatments on it. And let's just see the weight. So the weight for this animal was recorded 4 times. Now let's go on and delete this animal. So the animal is not deleted. Let's check it directly from the animals table. So the animal is gone, and so are its comments, issues, photos, treatments, and weights. So all the related information is gone when we remove an animal from the database. So I think that was it for this presentation.
Thank you very much. If there's any questions, you guys can feel free to come back and we'll be happy to clarify them. Thank you.
Thank you.